So at this point, what we're looking at are trees in 2010, and we can see there's quite a lot of healthy trees. There's a few red guys here, and Ohia trees die for all sorts of different reasons. They don't only die from the fungal pathogens associated with rapid Ohia death. They die for all sorts of reasons. But we can see a lot of nice, beautiful, healthy trees, and then a few scattered sort of dead trees. But then over time, if you can start to see, oh no, more of these trees are starting to go down. So this is from August of 2016. That's what we're looking at here. And then this is from, for example, August of 2017. And then we can see in just recent December. So there's this sort of time of initial pulse, and then it seems to stabilize a little bit. But it's these individual trees that are the basis for our understanding of what's happening in the Ohia forest. So my name is Dr. Ryan Peroy. I'm associate professor here at University of Hawaii at Hilo in the Department of Geography and Environmental Science. And my role in the work ongoing with rapid Ohia death is to basically collect high-resolution imagery and other types of spatial data that we can use to monitor changes in the forest over time. And also, when there are suspected new outbreak areas, we can also fly, and we use these small unmanned aerial systems, or people call them drones, and they allow us to collect high-resolution imagery so we can try and see what's going on.
So here's our Inspire 2. This is our main workhorse. This great backpack. I'll bring the camera along as well. They make these things modular, so we actually can input multiple cameras into the same thing.
So it's a pre-programmed flight, and you can think about it as something like when you're mowing your lawn, right? You sort of go back and forth, cover the area. For the type of imaging that we collect, it's really important to get a lot of overlap between images. And so we take hundreds and hundreds and hundreds of photos with about 75% overlap along these tracks, both in the forward direction and then the sort of side lap or side overlap. We take all these hundreds, in some cases thousands of photos, and we run them through a computer program, and we process them, and then we create what's known as an orthomosaic, or sort of one sort of collection of all of those photos put together. And then from those, and if we do this repeatedly over time, we can detect individual trees quite easily. We can detect rod symptoms on sort of even a branch level, and then we can see how things are progressing. We can also generate three-dimensional models of the landscape through a process called structure from motion. And so from the photos, from the raw photos, we not only get, as I said, this one large image, but we can also get these, they're called point clouds. And so they're somewhat analogous to LiDAR, but basically it's millions and millions of points which have been derived from all of these photos, which show the three-dimensional structure of the forest. The only way to really, at this point, know for sure if a tree has the fungal pathogens responsible for rapid Ohia death or not is to take a physical sample and to actually go to that tree and sample it. And so oftentimes if there are concerns about, is it spreading into this new area or not, it would require someone to go out in the forest and find that tree and sample it. And moving through the forest can be very dangerous, very time-consuming, takes a lot of energy, and so it's helpful for our partners if we're able to, from our aerial surveys, provide them with very, very good coordinates about where these suspect trees might be.